Hi guys, today we're going to be looking at a question on Doppler effect. The siren of a police car which is traveling at a constant speed along a straight horizontal road emits sound waves at a constant frequency. Detector P is placed inside the police car and detector Q is placed next to the road at a certain distance away from the car. The two detectors record the change in air pressure readings caused by the sound waves emitted by the sirens as a function of time. The graphs below were obtained from the recorded results, these being the graphs. Question 6.1. Different patterns are shown above for the same wave sound emitted by the siren. What phenomenon is illustrated by the two detectors showing the different patterns? This phenomenon, as we know, is known as the Doppler effect. The police car is moving away from detector Q. Question 6.2. Use the graphs and give a reason why it can be confirmed that the police car is moving away from detector Q. As we can see, this is the graph for detector Q. We see that the graph has longer periods, as here we have 25.5 and here we have 27 where it ends. This indicates that the longer periods are caused by a longer wavelength, therefore a lower frequency. And a lower frequency is heard when the object is moving away from the detector. Question 6.3. Calculate the frequency of the sound wave recorded by detector P. So this being detector P, we know that frequency is equal to 1 over period. We can see that 1 period, all the way from here till here, is 17. So we can say that 1 over 17, and don't forget the units over here, times 10 to the power negative 4. That is what the frequency is equal to. And if we put all of that into the calculator, we should get 5,88 times 10 to the power 2 hertz. Question 6.4. Use the information in the graphs to calculate the speed of the police car. Take the speed of sound in air as 340 meters per second. So in order to calculate the speed of the car, we need to get the observed frequency from inside the car and outside the car. So we need the frequency of detector Q. In order to get this, we can use the same formula we used there. 1 over, and this period goes all the way to 18. So 18 times 10 to the power negative 4. And if we plug that into the calculator, we get 5,56 times 10 to the power 2 hertz. We then can use the equation that the frequency of the listener is equal to the speed plus minus the velocity of the listener over the speed plus minus the velocity of the source times the frequency of the listener. We then have the frequency of the listener, which is 555,56 if you didn't use scientific notation. And this one is 588, is equal to 340, as that's the speed of sound in air. The detector, being Q, is stationary, so we can say plus 0. And since we want to calculate the velocity, we can say plus v. And we times that by the frequency of the source. And if we rearrange and plug all of that into the calculator, we should get 20 meters per second. And that's the speed of the car. That's all for this video. Thank you.